Thank you for this opportunity to give you this talk. So today I'm going to present this talk about sustainable mobility for citizens and the environment. So, as you probably know, it is estimated that by 2050, about 70% of the world population will go about their daily life in city. So from one side, city will be the beating heart of the world economy, and from the other side, they are responsible for 3/4 of global energy consumption and greenhouse gas emissions. So this is why cities are central to global climate change mitigation and the implementation of low carbon development strategies. So if we want to achieve the sustainable development goals, we need city to adopt an integrated strategy for sustainable development. And in my opinion, the global pandemic made the world population and governments aware that these are not utopian goals, but they are essential goals for our futures. So we have the Green Deal, so the United Nations Environmental Programme that strive to promote a coherent implementation of environmental dimension of sustainable development. And so what are the challenges of creating these sustainable smart cities? We have several challenges, but we have also several technologies that we can use. And I think the digital technologies are the critical enabler for attaining the sustainable development goals in many different sectors. So starting from AI, 5G, cloud and edge computing and IoT can accelerate and maximize the impact of policy to deal with climate change and protect the environment. So digitalization also presents new opportunity for monitoring of air and water pollution or optimizing how energy and natural resources are used. And moreover, an important aspect is the creation of a digital twin for the city that can help urban designer and governments and citizens monitoring the city and visualize plans and process before they occur. So a sustainable mobility requires a mind shift. This means that transport in private cars and trucking give way to different modes of public transport, like bicycle, pedestrian lane, electricity vehicles, car sharing, and so on. So creating solutions that ensure the virtual flow of people, goods, and services while mitigating climate change and creating climate-safe cities. So we also know that sustainable mobility is crucial also for having good air quality. So air pollution causes 400,000 deaths per year in Europe, making this the first environmental cause of premature death. And road traffic is one of the first source of pollution for air quality. So I've checked this morning also the air quality in Pretoria, and I think that is not always very good. During the year, it exceeds the limit several days during the year. And also in Cape Town, especially in summer, there are some peaks. So I would like to present here a project that I led for 2 years and a half that ends just at the end of April. The name of this project is TRAFAIR, that stands for Understanding Traffic Flow to Improve Air Quality, and it studied the impact of urban traffic flow on air quality in 6 European cities. So we involve several partners, 10 partners, and we have a quite a big project that help to monitor air quality and also traffic flow in the city and to understand how the traffic impact on the air we breathe. So the main goals are air quality monitoring and air quality forecast. So the monitoring is done by using low-cost air quality sensors that are spread in the city. And the forecast is possible thanks to a chain of simulation models. So how this chain works? We start with the traffic model that is a simulation model, and you can think this also as a digital twin for road and traffic in your city. So it takes as input the information coming from traffic sensors or also other information from mobile phones and so on. So it has an information in single points in the city, and it is able to transform this information in a traffic flow. This traffic flow cause emissions, so we can estimate the emission coming from the traffic model. And these are the input of another model, that is the air pollutant dispersion model, that use building shapes and weather forecast to understand how the emission moves in the air, how the particles moves in the air, and to understand also the forecast for the next day. We also add other pollution sources like energy consumption, domestic heating, and waste management. And in the end, we have a urban air quality forecast for each city. So this means we know what will be the air quality for tomorrow and the day after tomorrow. But what does it mean, a traffic flow model? So a traffic flow model is a model that simulates the movement of vehicles in a city. And so from this information, we can estimate what are the emissions caused by that vehicles in our city. On the other side, we have air quality monitoring. So we use low-cost sensors. So low-cost sensor has the power that they are low-cost. You can buy 100 of sensor instead of buying a very expensive legal station, but they need to learn how to measure air quality. So you need artificial intelligence techniques and a calibration procedure to improve the performance of these sensors. So we install that sensor in different positions in the city, and then we are able to create a real-time urban air quality maps. So this means that every 15 minutes we have an overview of the air quality we are breathing in the different points of the city. Actually, we are also working to embed this low-cost sensor on bikes, so also engaging citizens in this air quality monitoring in the city. So we provide results as open data, so on the European open data portal and also national open data portals, but also through dashboards and mobile app, so we can involve citizens, companies, and public administration in understanding how the traffic is going and how the air quality is going in their city. A very interesting aspect of this project is that you can also simulate new traffic scenario and evaluate the impact on air quality just with one click. So since you have your model for the traffic and you have also the model for air quality, you can simulate how a change in vehicle flow, such as road restriction, vehicular limitation, or in the vehicle fleet of your city might have a good impact on the air quality in the urban scenario. So this is what we obtained, for example, in Modena. As you can see, starting from the current situation, we simulate two other new scenarios where the vehicle fleets is improved. So we added more electric and hybrid vehicles, so their emission decrease, and it is very easy to see that we have very few red roads in the city. So this means that the emissions are limited in these new scenarios. On the other side, we also added an extraction of news, so city events from newspapers. And these city events are quite useful to understand particular events that might affect traffic in the city. We have done this also by identify with natural language processing what is called 5W plus 1H, that is where, what, when, who, why, and how in a single news. And for the future, we are working on traffic prediction. So we would like to understand what will be the traffic of tomorrow or next week by taking into account the historical simulation, but also other information like holidays, planned events, activity-based traffic analysis, and so on. So I have concluded this talk. These are my contacts. So thank you very much.
Yeah, thank you very much, Professor Po. It was a very, very interesting talk that combines all the elements that we are discussing here in this conference, including citizen science. Yeah, that's fantastic. Thank you very much. Are there questions from the audience in Pretoria or from the online participants? Because we still have a minute or two in this first talk.
Any questions from the audience? No questions from Pretoria.
Okay, are there any questions from the online participants? And please just speak if you have a question. Yeah. And maybe I can ask you, since we have another 45 seconds, I can ask you a quick question. You mentioned these low-cost sensors. Yeah, that's really very interesting because I'm a big fan of Raspberry Pis and Arduinos and things like that. Do you see also the possibility of really inviting the citizens to actively contribute to this modeling and to the collection of the data, instead of just providing them and give, so that they can do a more creative contribution to your efforts?
Yeah. Yes, we plan a new project, but we don't know if it will get funded or not. And in this new project, for example, in collaboration also with some companies in Italy, we would like to involve citizens and provide them a sensor that they can place on the bike, for example, and while moving around the city, they can measure air quality, and so we might have also information regarding a specific path that you can travel. If you want, for example, usually you understand that maybe crossing a park is better than ride your bike near a traffic junction, but you might have in this case the real measurements from your sensor. What is not very easy is to have very precise measurements, because air quality sensors are very sensible to different change in temperature, humidity, and so on. And it is also different to measure particulates or gases But we are involved in collaborating with companies also to test new products, and I think that this is the best period to try to test new sensor and use them.